Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over systems of equations, but today we're going to use a different method. We're going to use a substitution method. So I already have written down here what that method is. It's simply another method because unfortunately our graphing method, it doesn't always work. We don't always have a perfect ordered pair with two whole numbers in the ordered pair. That doesn't always work. So that is one method, but we have other methods just in case that one doesn't work. So this method involves substituting equations within one another. So think about the word substitution. If I have a substitute in class, a substitute teacher, then that teacher is there in place of me. I am not there. So that's kind of what we're doing. We're going to replace one equation into the other equation, and we're going to take something out. So here are the steps. Step 1, we're going to solve one of the equations for x or y. And in this case, sometimes this step is already done. So if you look at our first example here, what I mean by solving for x or y, you want to have that variable x or y on one side of the equal sign by itself. So this first equation, y equals, it is in that format. Actually, the second equation is 2. So that first step is already done for us. Then after that, since we know that y equals that right side, we know that this 4x minus 1, this is the exact same thing as y, because our equation tells us that it's equal to y. So what we're going to do is take the 4x minus 1 and we're going to substitute it into the other equation. So we're going to substitute that expression into the other equation, and then whatever variable is left, then we're going to solve for that variable. So let me show you what I mean by this. So like I said, this 4x minus 1 is the exact same thing as y. So we're going to take that and replace it in the second equation in place of y. So that substitution means we're going to take out y, and then instead we're going to replace it with 4x minus 1, because we know that's the exact same thing as y. And then we're going to continue writing that second equation exactly how it is. So 4x minus 1 equals 2x minus 5. So once we get here, all we have left now is the variable x, so we're going to solve for the variable x. Now before we do that, remember that we do want to get our variables to one side. They're both positive, so we'd have to subtract them. I'm going to subtract 2x, and that way we get our x's on the left side. So this is just like solving an equation which we learned this year. So the 2x is gone from the right side. 4x minus 2x, we're left with 2x minus 1. And then that all equals, we still have that minus 5 or negative 5, same thing. And once we get here, well, it's a two-step equation. So get rid of the negative 1. So 2x equals negative 4, and I did that by doing the opposite of negative 1 and adding 1 to each side. And then divide by 2, I'm kind of running out of room here. So x equals negative 4 divided by 2 is negative 2. So there I just solved for the variable x algebraically. Now that was step 2. After that, step 3 says we're going to substitute the variable that we just solved for. So I have the value of x. I know what that is. So I can take that value of x, substitute it into either equation, and then solve for y. So we're going to substitute your answer into the revised equation from step 1, and then solve for the other variable. Okay, so that was step 1 there. Now, and really, you can plug it into either equation. What you're solving for is what the y variable is, so it doesn't matter. We want it to fit both of these equations. So whatever equation you'd like. I usually try to pick the easier one, maybe the one with positive numbers, the one easier to work with. It really doesn't matter. So I am just going to take the first one, y equals 4x minus 1. And then what we're going to do is take that variable of x, which we got x is negative 2, and I'm going to replace it. So I'm going to do 4 times, and then instead of x, I'm going to do negative 2. And then I'm going to subtract 1, and all of that is going to give me my variable for y, or my value of y. So 4 times negative 2 is negative 8. Negative 8 minus 1 is negative 9. So y equals negative 9. Now, there is one extra step that actually isn't listed here, and we should include, and I'm going to put it actually over here at the very end, and I'm going to say step 4, write solution as an ordered pair. So we know by now that systems of equations, we're looking for an x and a y, and we write all of our solutions as an ordered pair. So x has to go first, so x was negative 2, and then y was negative 9. So negative 2 comma negative 9 is our solution. And you could take the time to go back and double check, does that actually fit into both equations? Plug in your x, plug in your y, and see if the two sides equal each other. So there is a method to solving algebraically. Let's try another one. Y equals 6x, so we have one of these equations is set equal to y. We have y by itself there, so we know 6x is the exact same thing as y. That's what that equation is telling us. So in place of y, we're going to substitute 6x into that second equation. So I'm going to write that second equation exactly how it is, 2x plus 3, but then in place of y, instead of writing y, I'm going to write 6x. Now when we plug them in, we always plug them in parentheses. Sometimes we may have to distribute, so always plug them in with parentheses. And then that equals negative 20. I just finished writing that equation. So second equation is written, and then I took out the y and replaced it with 6x. So now we will want to solve this equation that we just wrote for x. We have two x's, but same variable, so we can combine them. Now first, we do need to multiply the 3 times 6x, so we get 18x. So we have 2x plus 18x equals negative 20. Since they're both the variable x, we can combine those to 20x. So 20x equals negative 20. Divide by 20 to get x by itself, and x equals negative 1. So there we just solved for one of the two variables. So next step, now we know that one variable x, doesn't matter which equation. Now personally, I think the y equals 6x is a lot easier and shorter equation to work with than the second one. If you want to do the second one, you can, but it's probably going to take you a little bit longer. So I'm going to stick with the first equation, y equals 6x. Since I know my value of x is negative 1, I'm going to do 6 times negative 1 to get my value of y. So 6 times negative 1, y equals negative 6. And then last and final step, don't forget to actually write your solution out as an ordered pair. So x we got negative 1, y we got negative 6. So there is our solution. Okay? Now I'm going to pause here. I'd like you to try this next one on your own. We do have the variable y already solved for. So you want to take x plus 9, and you want to substitute that in place of the variable y in the second equation. And then you're going to solve for x, substitute x in, solve for y, and write your solution as an ordered pair. So I'm going to write the second equation, 3x plus 8, and then in place of y, I'm going to write that x plus 9. And then finish the equation equals negative 5. Make sure you stick with that second equation. You don't accidentally combine the two. I see that often. So we will distribute in this scenario. So the 3x stays how it is, plus 8x, and then plus 8 times 9 is 72. And that's all equal to negative 5. We can combine these two. I'm also going to subtract 72, at the same time. So 3x, 8x, we get 11x equals negative 77. Divide by 11, and we get x is -7. All right, there was step 1. Now we've got to get our y variable. Again, I find that first equation a lot easier to work with than the second one. Totally your preference. So we will replace x with -7. We'll add 9 to get our value of y. So y equals 2. And then last and final step. Whoops. Maybe. There we go. And write it as an ordered pair. So -7, 2. All right, awesome job. Last example. Now this one, we have an x equals, and that's okay. This may happen. In that first step, it said we could have an x equals or a y equals equation. Now the only difference is this 4y plus 7, that is the same value for x. So when we plug it into the second equation, it needs to go in place of x instead of y. So I'm going to write the second equation, 2 times x, but I'm going to replace x with 4y plus 7. And then rewrite everything else in that second equation. So -6y equals 12. Now we're going to solve this equation, but notice we have y in the equation, so we're actually going to be solving for y first. So 2 times 4y, 2 times 7, and then the -6y equals 12 stays the same. So we can combine like terms, and then I'm also going to get rid of my constant at the same time. So then 8y minus 6y, we get 2y equals, and then I also subtracted that 14. So 12 minus 14 is -2. And then all we have to do is divide by 2 to solve for our variable y. So y equals -1. Now, the only difference is, in this next step, we need to make sure that we're plugging in y as -1, and that we don't forget and plug it in as x. So, again, either equation works. I'm going to stick with that first one and go with x equals 4y plus 7. And then I'm going to replace my y. So we'll do 4 times y we found out was -1. And then plus 7. So I'm going to solve everything on that right side to get my variable x. 4 times -1 is -4. And -4 plus 7, x equals +3. And then our final step of writing the ordered pair, make sure you write the x variable first, because that scenario we solved for y first. So I often see we'll write the ordered pair as -1, 3, and that would be wrong, because our ordered pair, the x has to come first, which was 3, and then the y, which was -1. So 3, -1 is our solution. All right, so there is our second method to solving systems of equation, and that is all algebraic. We don't have any graph to see when we're substituting an expression into another equation to solve for a missing variable.